Hi everyone, welcome to another episode. Um, Again, I'm lagging a little bit behind on my daily challenges because of work, but let's don't waste any time and get on with the question. Today, we'll be looking at implementing a try. It's a prefix tree. Don't let the terms, scare you away. Like try prefix tree, like it seems like a very complicated um, concepts, but they are pretty straightforward. It's all about the visualization, and once we have the picture clear in mind, we can just code it off. Okay, moving forward, implement a try with insert, search, and starts with methods. So you're given an example. Let's say given a try class, you create an object of try, and you insert apple. Okay, that's cool. When you try to search, it should return true. Okay, when you try to search app, it should return false, obviously, because search means we are trying to, sorry, we are trying to search the whole word. So app is not a word. If we did a try insert on app, then it would be a word, and then it we would return true. Try that starts with app. Yes, so starts with is like we look for the prefix, and prefix app exists because we already have inserted apple. Similarly, now we insert app and we try to search app, and it returns true. Let's look at the constraints. You have to assume it's a lowercase letters a to z. Okay, all inputs are not empty string. Okay, so before moving forward, let's look into the approach. So try is nothing but an array tree. Okay, now we are going to see how we implement it. So um, in the input we are given that it's it only consists of lowercase letters. Okay, so what we do is, let's say we have a root. So root is here. Okay, now root is gonna have uh, a to z children's, a, b, c, and then to z, right? Similarly, for a will have a to z children, for b will have a to z children. Basically every node is gonna have 26 children. So like how in binary tree we have 0, 1, or 2 children's, right? In a try we have 26 children's. Okay, so let's look at the example a p p l e. So what we do here is, our root is the starting letter. Let's say root, obviously root has uh, uh, 26 children, so we have a root here. Let me mention it by r. Now root is gonna have first a node as because letter is a, the starting letter is a, so a will add a node here at a, and all other nodes will be null, right? Till z it will be null right now at the start. Now for a, after a, what's the next letter? B. So for the node a, will have the starting letter as null, and then b would be null, but p wouldn't be null, right? Similarly, we will have p again here for its child, and then l, and then e, right? So this is our tree. Let me draw it in a clean page. So our apple would look something like this. This is our root, a, p, p, l, e, right? Okay, now what we do here is, because we are trying to search for a word, we know in future we'll be trying to search, we just do a traversal. So when we first, during the insert, we insert three try nodes in this places, a, p, p, l, e. When we try to search, we just do a dfs on this tree, and if we reach, and when we insert, what we can do here is we can have a flag at each node. So this node can have a flag called isEnd, right? IsEnd flag, which means if this is the end or not. So we'll set this isEnd flag to true here for E. So when we are searching, when we do a DFS, when we reach E, we check if this flag is set. If it's set, we return true, that we are able to search. In case of, so insert is done, search is done, right? Now what about starts with? So starts with is pretty simple. Again, we just do a traversal DFS, and when we reach P, app, the prefix, we return true. Let's try to look at the approach, and I will try to do it in Java. I'm gonna take a try node, class, and then I can have node array like this, and as I said, I'm gonna have a boolean flag is, and now I create a constructor this dot ARR is equal to new try node will create a 26. Okay, so because it's gonna have 26 children, but initially they all will be null. I just keep a root. I can create try node root. So I'll keep a root object access here, and when I create a public try, so when I create a try object, I do root is equal to new try node. So the root will start having 26 children, and then each of that children will be another 26 children, right? So this is done. Then we try to do insert. So okay, so public, this method is already there. So now we look into insert. So insert is pretty simple. If word is, I think word is, they said is gonna be non-empty strings. Okay, so I can keep a temp variable, try node root temp for this method. Just because I don't want to mess up the root, so I take a copy of the root node in another node, and then I start my traversal. Okay, so character C is equal to I'll get the character at I. I'll take the index. Index is nothing but the ASCII value. We can take it. So if C is, let's say the first character is A, right? So A ASCII value is 97. So 97 minus 97 is 0. So we know it's A will go at index 0, B will go at index 1. Similarly, Z will go at index 25, right? Now if P dot root dot temp dot array index, so if this element doesn't exist, then we need to create, else we just do the traversal. So our traversal would be, I'll assign root temp dot array at that index. So I'll just move on to the node, because let's say in future, let's say I have apple already inserted. Now when I get app, I don't want to create a new node of A again, because it's gonna remove the existing one. So I just keep on moving forward, right? And then so I can create I can create another node, try node. So this will initialize with 26 null children, and then root temp dot at index will insert that tree node, and then my root temp will become temp T in the sense. This is T. So this will become T, and I'm just doing a traversal. Now once I reach this end of the for loop, whatever reference I have, I'll just set the isEnd to true, because I know the last letter defines the end of the word, so I would like to set it. Now let's try to search. So in case of search, if I can again create a triangle root and root, and then if root temp equals null, then we just return false. Else if we reach the is n, because for the word search we need to reach the is n, right? So then only we return true. If none of these happens, we will return false at the end. So this is our search done, and then so this starts with but we need to do the traversal. So what we can do here is I created a search word, so we need to do the traversal, right? So what we need to do is we can run a while loop. So we are trying to search the word, right? So for n-ary equal to 0, same thing what we did here, we can copy this. So word dot length character at I, but at the index is equal to c minus a. Okay, and then if root temp dot array at index equals to null, then we return false, because it doesn't exist, right? And then else if it's not null, we just do root temp is equal to root temp dot next. We are just trying to traverse, so I go to the child node, I go towards that child node, and then if I reach the end of for loop for some reason and my root temp is null, it's written false, it should be true. Yeah, so this is done, and then we can look into the starts with so maybe I can create a new method which could be private to this class, private traverse, and I can put all this in that, because starts with will also require the traversal. Return null. So we return this, and then here correct, and then try node t is equal to traverse prefix, so it shouldn't be null. In this case, if we reach null, then we return false, else if it reaches here, it's true, right? That it exists and it's not null. So let's see, this should work. null, null, true, false, true, null, true. Okay, seems to work in this case. Awesome, it worked. Pretty straightforward approach, and it's not at all difficult if you try to visualize it. Hope you guys like this video. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.